Hello and welcome back to the 5.2 notes. This is part 3, and I want to go through problem number 12 with you, and this is kind of a word problem using a table and a graph. And so what it wants us to do is to calculate the distance of a car traveling over a 36-second period, and this is and we're given the velocity data. So we're given all these different times and all these different velocities, okay? And we're also given this graph, okay? So it wants us to calculate how far the car traveled during the 36 seconds it took to reach 142 miles an hour. Okay, so what I'm going to do here is remind you guys of how we do that, okay? Now remember, if we're trying to find distance, we want to multiply the rate times the time, and that's going to give us our total distance. So if we take this axis and multiply it by this axis, it's going to give us the total distance. So here's what I've got, okay, and I'm going to show you this. Distance is equal to the rate at which we travel times the time. And what I know is that distance is equal to, okay, the rate that we've got is miles per hour. And if we multiply that by the time, which is hours over 1, the hours divide out. And so our answer, when we calculate the area here, okay, this axis times this axis, we get a measure of miles, okay? So that's the idea. Okay, now the first thing I want to do, step 1, okay? Step 1 is calculate delta x. Okay, so step 1 is I want to find delta x, okay, and I'm going to call this delta t because we're dealing with a measure of time. And let's go ahead and take a look at what we've got here. What I see based on this graph is that I have 10 spaces from 0 to 0.01, okay? And if I want to use rectangles to estimate how far I go, my best estimate here is using MRAM. So I'm going to use MRAM here, okay? And so I'm going to need to know some sort of midpoint. So my thought process tells me, well, how about this? I know I have 10 spaces. How about I split it up and so that each rectangle has a width of 0.002? Because I have this midpoint here that I know the height of, okay? So let's do that. Let's choose delta t to be 0.002, okay? Now what I'm going to do is I'm going to come down here into my interval, and I'm going to call delta t equal to 0.002. Delta t is equal to 0.002. Delta t is equal to 0.002. Oops, okay, let's go over here. Delta t is equal to 0.002, and then delta t is equal to 0.002. All right, so what I'm going to do is partition this off into these different, so all these different partitions. I've got 5 of them. And so what I'm going to do is try and use these midpoints to draw our rectangles, and we'll use those midpoints to give our height. So what I want to do is find the midpoint here. So I want to start and go up at 0.001, up to my function, draw my rectangle, and draw those down. Okay, start at 0.003, go up from there, okay, and get to that point here, draw a rectangle over, and then go down. Okay, and repeat that process. Okay, but we got to make sure we're using the midpoint. Okay, and that's why I chose to do a delta t of 0.002 was so that I could actually use the points in between and use those points to find my heights, okay? And last one, okay, all right. So we'll use those. Okay, so we found our we found our delta t. Okay, now what we need to do is we need to find the different heights. Okay, and what it's hard for me to tell these from the graph, but that's why I used, we have the table here to help us. So the nice thing is that for these different times, I have the different velocities. So I'm concerned about the one at 0.001, 0.003, 0.005, 0.007, and 0.009. So what I'm going to do is come in here and circle these values with what I want. Okay, and I want 0.001, that's 40, 0.003 is 82, 0.005 is 108, 0.007 is 125, and 0.009 is 137. So I'm going to write those down over here. Okay, so step 2 is I want to find all the different heights. So I'm going to find my velocity at 0.001, which is 40. My velocity at 0.003, which is 82. My velocity at 0.005, which is 108. My velocity at 0.007, which is at 125. And then my velocity at 0.009, which is going to be 137. Okay, so now that leaves me with step 3. Okay, and I want to write all this stuff out. And so step 3 is and I want to write this out in integral notation. So I'm trying to calculate the area under the curve between 0 and 0.01 under my velocity function v of t dt. Okay, so this is approximately equal to the following. Okay, I'm going to take delta t, so delta t times my velocity evaluated at 0.001 plus delta t times my velocity evaluated at 0.003. Okay, so plus delta t of times the velocity evaluated at 0.005 plus delta t multiplied by the velocity evaluated at 0.007, and then plus delta t times the velocity evaluated at 0.009. Okay, so now I'm just going to plug in the values that I have for this. Okay, but I need to rewrite this and say that my integral between 0 and 0.01 of my velocity function dt is approximately equal to the following. I'm going to do 0.002 times, okay, what's my height? All right, 40. All right, plus 0.002 times 82. All right, plus 0.002 times 108. All right, and then 0.002, so plus 0.002 times 125, and then plus 0.002 times 137. Okay, so now what I can do with this, all right, I'm going to rewrite my integral symbol, and I'm going to say from 0 to 0.01 under my velocity function v of t dt. Okay, I can factor it, because my delta t is the same for each of these, it's 0.002, I can factor that out, 0.002, and I'm going to multiply that by 40 plus 82 plus 108 plus 125 plus 137, okay? And so as a result, all right, let me add those up, but first let me rewrite this as the integral from 0 to 0.01 of my velocity dt, and this is approximately 0.002 times the sum of all those numbers, which is 492, okay? And if I multiply 0.002 by that number, 492, then I'm going to get this, okay? I'm going to get from 0 to 0.01 v of t dt, okay, the distance is approximately 0.984 miles. So almost a mile traveled in 36 seconds. Okay, so if you reach a speed of 142 miles an hour, okay, you can approximately travel that far. Okay, and that's what I'm just trying to figure out is how far they traveled. Okay, and that's by calculating the area under the curve. Okay, again, this value here, whenever I write this integral, that means the exact value, but I'm just approximating it. So there should be approximation symbols here. Okay, we'll learn how to do that later, but we need to be concerned about how to set this up. Okay, but I wanted to use this notation and show you this is what I expect to see from you guys on your homework. Okay. Now I want to continue on and do the last problem here, and so what it's asking us to do is to figure out this information based off of a table. Okay. And so we have our interval here from 1 to 5, and we have our number of rectangles, which is 8, okay? And so the first thing I want to do is let's go ahead and just graph these points, all right? So I'm going to do this. I'm going to do, and we want to do an LRAM and an RRAM from this, okay? So I'm going to go from 0. I'm going to do 1, I'm going to do 2, I'm going to do 3, I'm going to do 4, I'm going to do 5, okay? And we have our values in between. We've got 1.5, 2.5, 3.5, and 4.5. And then our y values range from 0 on up to 3, so I'm going to do 1, 2, and then 3 here. And I'm just going to plot my points. So 1, 0. I'm going to plot the point 1.52. Okay, 2 and then 3. And then 2.5 and then 2. Okay, 3 and 2. 3.5 and 1. 4 and 0. Okay, 4.5 and 2. And then 5 and 3. Okay, so I'm just plotting those points. And I'm going to come in here and I'm going to kind of draw a smooth curve as best as I can. Okay, it's not going to look pretty, but we're going to do our best. Okay, so there's our curve. All right, and so the first thing I want to do is figure out my delta x. Okay, that's step 1, and that's going to be the same for both. So step 1, all right, we want to calculate our delta x. We're going to use our interval, which is 5 minus 1 all over 8, which is going to give me 4 over 8. So my delta x is equal to a half, okay? So what I want to do from this now is figure out step 2. Now I'm going to, because step 1 is the same for each of the problems, okay, I'm going to split this up and do this for LRAM and then for RRAM. So for LRAM, okay, remember we want to start at the left and move right, okay? And I'm going to go in and make my, my rectangles for LRAM. All right, so I'm going to come here and I'm going to draw this line, start on my function, okay, the point at 1 is at 0, so I don't have anything there, okay? I'm going to go up from there, get a point, move that over, draw a line down, okay, come over here, go up to my function, draw a line over and go down. Same thing here, draw a line over and go down. Start here, start at the left, go to the right, go down. Okay, here we go from here. And then we have a height of 0. And then go up to my function, plot point, and then go down. Okay, so I know that each of these values have a width of 1/2, but then we need to find the heights. Okay, and the heights are determined by my table. Okay, so LRAM Okay, I'm going to do step 2, and that's calculate the height. So I want f of 1, I want f of 1.5, okay, f of 2, f of 2.5, disregard this information down here. I'm just going to cover that up with a nice little square like that. That takes care of that problem. All right, so then I've got f of 3. Okay, I've got f of 3.5, I've got f of 4, and then I've got f of 4.5. Okay, now all these different heights, I can figure those out from the table. So f of 1 is 0. Okay, 1.5 is 2. F of 2 is 3. F of 2.5 is 2. F of 3 is 2. Okay. F of 3.5 is 1. Okay. F of 4 is 0. And then F of 4.5 is 2. Okay. So now I want to do step 3. Okay, I want to add all these up. Okay, so step 3, all right, for LRAM, I'm going to use red. Okay, so step 3 is I want to approximate the area from 1 to 5, that's my interval, under the function f of x dx. Okay, and this is approximately equal to, all right, I'm going to do 1/2 times, hold on, let me redo this and say delta x times f of 1, okay, plus delta x times f of 1.5, plus, all right, I got delta x times f of 2, plus delta x times f of 2.5, plus delta x times f of 3, plus delta x times f of 4, or I'm sorry, 3.5, okay, plus delta x times f of 4, and then plus delta x times f of 4.5, okay? So what I want to do now is plug in what I have for these values, okay? But now, so now I've got the integral from 1 to 5 of f of x dx, and that's going to be approximately 1/2 times, all right, what do I got? 0 plus 1/2 times, okay, 2, 3, 2. Okay, so 2 plus 1/2 times 3 plus 1/2 times 2 plus, all right, 2, 1, 0. All right, so plus 1/2 times 2 plus 1/2 times, oh dear, sorry, 2, 1, 0. Okay, so 1/2 times 1 plus 1/2 times 0 plus, okay, plus 2. All right, so plus 1/2 times 2. All right, let me just verify that I've got 8 of these terms. I've got 1, 2, 3, 4, 5, 6, 7. Ocho, we in business, people. Okay, so now, since I have a common delta x, I can factor that out front. So I've got integral from 1 to 5 of f of x dx is approximately equal to 1/2 times, okay, let me do this. I'm going to do 0 plus 2 plus 3 plus 2 plus 2 plus 1 plus 0 plus 2. Okay? And so if I add all these up, okay, I get my integral from 1 to 5 of f of x dx is approximately equal to 1/2 times, all right, 2 plus 3 is 5, plus 4 is 9, so 10 and 12. Okay, and so then we end up getting that this is equal to 6. Okay, so the approximate area under the curve from 1 to 5 of f of x dx is approximately equal to 6. Okay, and that would be the approximate area under the curve. Okay, so that's LRAM. Okay, and what I want you guys to do is I want you to do RRAM on your own. And I'm going to check that in class. Okay, so please make sure that you do the RRAM part on your own. It is a part of your homework, I believe, I think. Not really sure, but I hope you enjoyed this. I know it's very tedious, okay, but we have to make sure that we, are able to do that. So, okay, I'm done talking. This is it for the 5.2 notes. Okay, please get started on your homework, and let's work on it. See ya. Bye.